Okay, so that was like a really weird jump to you. Question 9 of KA4. Really annoying to not be able to award more marks here than I was able to. So we've got the vertical height h in meters of a snowboarder above the ground has been plotted against horizontal distance travelled x meters. Meters may be useful and meters may be useful. The model is travelling in the vertical plane. So that's just tells us it's a flat thing. We don't need to worry about 3 dimensions. Reaches a max height of 1 meter above the ground, so that's kind of this point here, and lands 6 meters away. Told it's a quadratic, and we need to find h in terms of x. So what we need to use is a lot of ingenuity here. So the first thing, it's a quadratic. So if it was some random quadratic, it would look like this. And this isn't necessarily the fastest way to go about this, but it is the safest. Now, we've got 3 points, 3 unknowns, so we're going to need to know 3 points. Now, the obvious ones are the 0, 0, it goes to the origin, and 6, 0. So let's try dealing with them, see what we get. So 0, 0. So 0 is a times 0 squared plus b times 0 plus c, or 0 is c. Well, that's nice. So now with that, if we sub in 6, 0, we get 6 is a times 6 squared plus b times 6, or 0 is 36a plus 6b. We can make it a little bit easier, can't we? 6a plus b. Okay, so we need another point. We're going to need another point to make another equation. Let's get rid of that. Don't do that in a real test. Let me not do that. You can do that. Now that is this highest point. Now the thing about quadratics is that they are nice and symmetric. So that is going to be in the middle. Between 0 and 6, it's at 3. So we now know the other point is 3, 1. Remember, we know c is 0, so we can ignore that. b times 3. So 1 is 9a plus 3b. Easiest way, I think, to go about this is if we rearrange this b to be minus 6a. 1 is 9a plus 3 minus 6a. 1 is 9a, take 18a. 1 minus 9a. A is minus 1 over 9. So b is minus 6 minus 1 over 9. Or 2 over 3. And h is minus a 9th x squared plus 2 over 3x. Not the quickest way. And if you want to know some quick ways, you can ask teachers. But that is kind of the safest way. Okay. Part B and C from there are actually quite easy, or straightforward questions at least. Snowboarder passes over 2 vertical poles, height 0.5. Poles are in the same plane. You use a model to find the greatest distance between the poles. So we need to find where he's at a height of 0.5 meter, and then do the distance between them. I've got plenty of space. So find his height as a half. And I wouldn't worry about organising this too much. I do like to have positive x squareds, it just makes me feel nice. So move it all to the right. Quadratic formula. 3, oh no, that's just going to be jumping a bit. 2/3 plus or minus square roots. 2/3 squared minus 4 1/9 a half. All over 2 times 1/9. Ask our calculator. And we'll get 3 plus or minus 3 root 2 over 2. So the distance between them is going to be the difference between them. So it's going to be 3 plus 3 root 2 over 2, the bigger one. Take 3 minus 3 root 2 over 2, the smaller one. The 3's will cancel, we're left with, well, just 3 root 2. Did it want it to sum? No, we could leave it as that. Let's see what that is. 3 root 2, 4.24. Three sig figs if you want to round at all. Okay. Part C, give one limitation. So the thing that I would go for is he's not going to follow that path exactly. Don't we need that? And let's mark it. So it's an M1 for the correct setup and finding one of the unknowns, or using one of the cleverer setups but still correctly, which is kind of what's buggering some people. M1 for working to find the other ones, and then A1 for the correct final thing. The M1s kind of depend on how you've done it. But trying to solve these simultaneous equations is what's going to get you there. So I guess it would come more at this point. Part 2b, M1 for setting it equal, M1 for attempting to solve the quadratic, M1 for doing the difference between your two roots, and an A1 for either of those answers. And C is just a B1, either you said something that was correct or not.